So just like we did at the end of year 12, we're going to want to be able to use calculus to solve problems involving SUVAT motion variables. So we want to be able to integrate and differentiate to move in between velocity, acceleration, and displacement. The difference here in year 13 is that since you know how to apply differentiation and integration to much more complex expressions than you did last year, we're going to be able to involve these in our motion variables. So I'm talking about you being able to differentiate using the product rule or the chain rule, to be able to integrate by parts or by substitution, and even differentiating and integrating trig functions. Okay, let's have a look at an example as a reminder of your year 12 techniques. In this question, we were told that a particle is moving in a straight line with acceleration at time t given by this function. Acceleration, a, equals cosine 2 pi t meters per second squared. We've also been told that the velocity at time t equals 0 is 1 over 2 pi. First, we've been asked to find an expression for the velocity at time t seconds. Well, we know that acceleration is the rate of change of your velocity, so to move from acceleration to velocity, we should be integrating. So here I'm just going to start with the expression that we've been given, and for clarity, I'm going to say that velocity equals the integral of a. So I'm integrating this function. That's going to give me, according to the chain rule, 1 over 2 pi sine 2 pi t. Now, every time we integrate, we're going to generate a constant of integration. So I'm just going to write that as plus c. We were told that when time equals 0, our velocity was 1 over 2 pi. So that condition, that situation, should help us to find out this unknown constant of integration. Okay, so let me just set this up. I'm going to substitute t equals 0. That gives me 1 over 2 pi sine 2 pi 0. So that's all going to be 0. Plus c equals 1 over 2 pi. So sine of 0, I already know is going to be 0. So this whole left-hand term is 0, which means c must be 1 over 2 pi. Okay, so my full velocity function, now that I know the constant of integration, v equals 1 over 2 pi sine 2 pi plus 1 over 2 pi. So I could probably factorize that, but I'm actually happy with the form that it's currently in. Part B of the question asks us to find the maximum speed. Well, we've got the velocity in front of us, so we need to find the maximum magnitude of that velocity. So I'll check both the positive and the negative to see what the maximum comes out as. So looking at the velocity function that I have, I know that the maximum that I can take is when the trig part is maximized. So the maximum a sine function can take is going to be positive 1. This expression will be its largest when sine 2 pi t equals 1. Let's just substitute that in. So that will be 1 over 2 pi times 1 plus 2 pi. That's 2 over 2 pi, which cancels down nicely to 1 over pi. So 1 over pi meters per second. So that's going to be the maximum velocity. That's the maximum this function can be. But I should also consider the minimum velocity, because its magnitude may well be larger than 1 over pi. So I'm going to take a minute to think about it. And actually, there's two ways that I can demonstrate what's going to happen. Firstly, a sketch of this function. So this is going to be a sine graph that has been scaled horizontally and it's been scaled vertically. The vertical scaling lets me know that this sine function is going to oscillate. Instead of between 1 and negative 1, it's going to go in between 1 over 2 pi and negative 1 over 2 pi. That's before the translation that we have at the end. If it's been translated vertically by positive 1 over 2 pi, that means that this function is never going to be negative. Instead of oscillating in between 1 over 2 pi and negative 1 over 2 pi, it's going to be in between 1 over pi at its maximum and 0 at its minimum. So by considering the graph, I know that the minimum velocity is going to be 0, meaning the maximum speed is 1 over pi. We could have done this by substituting in negative 1, and that also would have got us an answer of 0. In part C of the question, we've been asked to find the distance travelled in the first 3 seconds. Well, I should then be able to integrate the velocity function in between 0 and 3. I know that this graph never goes below the x-axis, so I don't need to split this up into different sections for the integration. So I can just go ahead and integrate the velocity function with limits 3 and 0. Okay, looking at this, I already want to factorize out the constant. It's a bit of a complex constant, 1 over 2 pi. So I'll factorize that out, and I'm integrating sine 2 pi t plus 1. Okay, so in between 3 and 0. That gets us negative 1 over 2 pi cosine 2 pi t plus t. Okay, just substitute in the 3 and substituting in the 0. Okay, just into the calculator and we get an answer of 0.477 meters. That's the distance traveled in the first 3 seconds. That would be the area underneath the curve in between t equals 0 and t equals 3. Okay, let's have a look at an example where instead of trig, we've got the exponential function, and we're actually going to involve some of Newton's second law. So, looking at the question, we're told a particle of mass 6 kilograms is moving on the positive x-axis. At time t seconds, the displacement s of the particle from the origin is given by this function. First, we're asked to find the velocity of the particle when t equals 1.5. Okay, this should seem familiar. We're finding the velocity when we have the displacement. We know velocity is the rate of change of displacement, so I should be differentiating s, and that should give me the velocity. So we get 3t to the power of half minus 2/3 e to the negative t. Well, we want to find that velocity when t equals 1.5. So we'll substitute 1.5 into that function. So at this point, we should be able to type this all into our calculator, and we should get the answer 3.64 meters per second. The question then goes on to say that given the particle is acted on by a single force of magnitude F, so we don't know the magnitude, and it's acting in the positive direction of the x-axis, we should then find the value of F when t equals 2. So here we're going to use Newton's second law, F equals ma. We know the mass. The mass was given early in the question is going to be 6. The acceleration, though, changes. We have variable acceleration. So we want to find the acceleration when t equals 2, and then we can substitute. So let's start there. We have the velocity function, and we know acceleration is the rate of change of velocity. So we can find dv dt. We get 3 over 2 t to the negative half plus 4 over 3 e to the negative 2t. We're going to substitute t equals 2. That's the acceleration we're interested in. And from there we get acceleration equals 1.09 meters per second squared. If we bring in Newton's second law at this point, we're substituting the 6 and the 1.09, and we get 6.51 newtons. That will be the magnitude of the force being applied after 2 seconds when t equals 2. Okay, so just some sensible differentiating and integrating as necessary. But since your integration and differentiation skills are so much more improved from this point last year, you will have more complex expressions that you'll be presented with.